discontinuous functions are what we're messing with today. So they have a break in the graph, right? What we're used to is these continuous functions like our parabolas or just a linear function. All those stuff are just one solid line, but this has the break, right? If they were looking like this, it looks like two separate lines, right? It is two separate lines, and they have this asymptote that they never cross. Pretend like that's not just going to move around. Now, we're going to get a little wild with some of these functions, and we're going to end up with stuff like this. And we're going to be graphing that. Now, it's not bad, and a lot of the time we can use things like Desmos because we don't need exact procedures for it. But this can tell us a lot of important things. The numerator up top can tell us some of the zeros, some of the x-intercepts where this is going to cross. So it says x minus 3. So just like when we were factoring back in the day, that 0 would be x equals positive 3. So there's going to be an x-intercept at positive 3. This says x plus 2. So we're going to have another x-intercept at negative 2. So the numerator, maybe I can write this somewhere. The numerator gives you the intercepts, or the zeros. The denominator is going to give you the asymptotes, just like with the transformation we just did. So it says x plus 1. So there's going to be an asymptote at negative 1. You know what I'm saying? So it's going to give you a vertical asymptote. So you'll see what I'm saying here when we go over our first example. Identify the zeros and the vertical asymptotes of this function. And then it says graph. Now you can substitute in values for x, not the most important thing, and solve each one of them. I just want to get you kind of with how the graph looks, like a quick sketch of it. So again, the zeros are messed with the numerator. Now the numerator is not in factored form. So if we were to factor this, factors of negative 3 that add up to negative 2 would be negative 3 and positive 1. So that would factor to, goodness. That would factor into x minus 3 times x minus 1. The denominator is x minus 2. So the zeros in this case, or the intercepts, the zeros, remember, are the numerator stuff. Is there a second E in zeros? I don't know. Ugh. So the zeros we have positive 3 and positive 1. So there are going to be intercepts at positive 3 and positive 1. Now the vertical asymptote, the VA, we get from right down here. It says x minus 2, so that would be shifted to the right 2. So there's going to be an x equals 2. There's going to be a vertical asymptote. Now I have this graphed from Desmos.com, proud sponsor of Mr. Plant's classroom. And this is what the graph looks like. And I'll scooch it out of the way here in a second. So if you look, we do have the zeros. It's got zeros at positive 3 and negative 1. And then it's got the vertical asymptote at x equals 2, which is this line right here. Well, I got off the line there. But neither of these parts of the hyperbola will touch that vertical asymptote at x equals 2. So figure out your zeros with the numerator, figure out your vertical asymptote with the denominator, and you're good to go. So I have this one that I would like you to just factor it, see if you can identify the zeros and the asymptote, and then we'll look at the graph together, okay?